Greetings and welcome to the introduction to astronomy. In this week's special topic in astronomy, we are going to talk about elongation and what that means in an astronomical sense. So what is elongation? Well, the definition of this would be the angular distance between the sun and a planet as seen from Earth. So we're looking from Earth, looking out into the sky, and we see the sun and we see how far a planet is away from it. Now, in general, it refers to what we call the inferior planets or interior planets to Earth, those that are closer to the sun than Earth, and that would be Mercury and Venus. Now, the elongation can be considered either an eastern elongation or a western elongation. So an eastern elongation would mean that the planet is to the east of our sun. And if it's to the west, it would be to the western elongation would be to the west of our sun. And that determines when it would be seen in the sky. So for example, if the planet is to the east of the sun, then it is going to be visible just after the sun sets. And if it is to the west of the sun, it would then be visible just before the sun rises. So those will tell you what part of the sky it's in, whether to look for it right before sunrise or right after sunset. Now for the inner planets only, there are also terms that we call the greatest elongation. So there is a greatest eastern elongation, which is the best time to see an inner planet. That's when it is visible right after sunset, and it's at its greatest distance from the sun. Now, if the planet is too close to the sun, it's hard to find. Why? Because the glare of the sun is there and it makes it very hard to see a planet. And especially Mercury is tough with this because it isn't all that bright in the sky. So that's the best time to see one after sunset. The greatest western elongation would be the inner planet visible just before sunrise to find it in the morning sky. Now, how large are these? Well, it depends on the planet. So there are two planets that are closer to the sun than Earth, and that would be Mercury. And Mercury with a highly elliptical orbit can range an elongation of between 18 and 28 degrees. Now, that is not all that far above the horizon. As comparison, Venus is about 45 degrees. That's about halfway between the horizon and the zenith straight overhead. Mercury can be only about a quarter or less of that distance. So it can be very, very small distance, making Mercury really the hardest of the planets that are visible with the naked eye to actually see. And that's because it's never very far away from the sun. A way to judge this is if you hold your fist out about arm's length, your fist subtends an angle of about 10 degrees. That's an approximation, but it works pretty well for most people. So that's about 10 degrees, meaning that for Mercury, 2 to 2.5 fists worth is about all you get above the horizon. And as we know, the sky doesn't get dark immediately. So as soon as the sun sets, it has to get well below the horizon before the sky actually gets dark, allowing you to be able to see the planet there. So let's go ahead and finish up our discussion today with our summary. And what we've looked at today is that elongation is the angular distance between the sun and a planet as seen from the Earth. When it's applied to the inner planets, we get the greatest eastern or western elongation. And these tell us the best times to observe the inner planets, Mercury and Venus. So that concludes this discussion on the astronomical term elongation. We'll be back again next week for another special topic in astronomy. So until then, have a great day, everyone, and I will see you in class.